Hey TypeScript fans! In my last video I've shown how to fix issues with TS Node to get your TypeScript code up and running just from the command line on Node.js. And we've seen that the setup was taking quite some time and also needed some adjustments in order to work with the latest Node.js versions. And that's why we will explore some alternatives today. But first I want to do a little recap what we've seen, and then we will go through various options. In my previous video, I've shown how to use tsc noemit to do the type checking and to use the ts node loader for transpilation of TypeScript code. This is the current solution to fix all ts node issues with ECMAScript modules and later Node versions. And we discovered that it's a very big line and we need two different tools to do the job. We then, in my previous video, have looked into TSX and we were able to shorten this big command line, but still a lot of work in order to just do type checking and running TypeScript code. That's why we will check in this video if there are other alternatives. And we will go through a lot. Hey, look what I found! Another TypeScript import loader called ts-imp. That actually reminds me on the imps on Dungeon Keeper. Yeah, if you ever played Dungeon Keeper, that might sound familiar to you. And ts-imp says that it has full type checking support with acceptable performance. So, well, hopefully we get now our one tool to do the type checking, the transpiling and the execution, the running. Yeah, it also says that there are already quite a few TypeScript loaders. It mentions TSX that we just tested. It also says that TS Node is probably the most established one. Yeah, we've seen it is working quite well in Node 18, but with Node 20 things with ESM become a bit difficult to configure. And it also mentions SWC, so there is another TypeScript compiler implementation in Rust that could be used alternatively to run TypeScript code. Well, a lot to read, right? A lot of competition here in that market. And we also see that it supports here the import flag and that this behavior was added in Node version 20.6. So if we look further on the usage, we actually see the loader flag that we've seen in Node 18 and Node 20, where it got also then marked as deprecated and experimental. And we see that Node 20.6 and higher should use the import flag according to this documentation. Long talk, let's keep it short and let's start to use ts-imp. I will just copy over that command here and then I will switch back to VS Code to see how it performs. All right, back in VS Code. This time we want to use ts-imp. So let's install ts-imp. And then let's see how we can leverage that in our start command. So once it's installed, I will replace our start command and I want to have then Node and I want to specify a loader, which is the ts-imp loader. And then I want to use my code here in the source directory and the main file. We also need to check our Node version. I'm on 18 and I also, do I want to use ECMAScript modules yet? Well, let's see how it performs without, because we are still on CommonJS. If I'm running ts-imp, it works. Yeah, so we have it working with not ECMAScript modules, with CommonJS. Let's switch the type to module, so we have ECMAScript modules, and then also adjust our configuration for TypeScript accordingly. Node 16 or Node Next would work. I'm not using Node Next because it's the next, quite not to say experimental, but it is always on the edge. Yeah, if there is a new Node version, then Node Next will point to this new Node version. And with Node 16, I can at least pinpoint it to the module resolution that was used starting in Node 16. So let's see how it performs. If I run npm start, I get a reference error here. Export is not defined in ES module scope. I'm having module set here. I'm having set Node 16 here. that was actually the fix that we had to use with ts-node. So I'm not knowing why it behaves like this. I see also that there's a caching directory. ts-imp creates that to build up from the last compilation to be faster. Let's see if I can delete this caching directory and run it again. And then we'll see the output. So there's already our first issue with ts-imp. It builds up on a cache. And if you don't refresh the cache, in some cases it reuses it where it shouldn't reuse it. And that's quite difficult to debug, because I was just like deleting that directory because I knew of that issue, because I've filed it. But if you don't, you think you have done everything properly because you're using the loader flag, you have set your type to module, you have set this here to node 16, so that looks all correct, and it wasn't working, right? So I had to delete the cache, and now that it builds from the cache, it will probably work just fine. Let's continue a bit here. We have experimental warning again, right? So we could then change this here into the no warnings. So that's similar what we had with ts-node. Yeah, we have now the suppressing of warning messages. If I run it, works fine, no warnings any longer. Let's use a more recent version of Node. So I have now 18, let's say nvm use 22. Now we are Node version 22. What happens if I run it here? Runs fine. What happens if I remove the warning filtering? Well, then I get a warning. But luckily, and that's quite cool for ts-imp, ts-imp supports also the import flag. So I can say instead of loader, use import. And then here I will also change that to import. I will run it again. And it works fine. Yeah, and this is also what we've seen in the README, that in Node version 20.6 and above, you should use import instead of loader. That's actually what I quite like about ts-imp. Yeah, it's using here the latest and greatest, and it is also doing hopefully both things we haven't tested yet, which is type checking, transpilation, and execution. So let's go to main, and let's build some code that is not working. So now we have code that is not working. Let's see how it performs with ts-imp. I get the stack trace, but that's also an interesting discovery with ts-imp. I get the stack trace, which is cool, but it also executes the code. Yeah, it did the logging here. Let's see, question mark, question mark, question mark, to just see if there's a new version. Yeah, it runs the code. That's quite a mixture of what we've seen before, like with tsx. tsx was not giving the stack trace at first, yeah, and was then just running the code. ts-imp is giving a stack trace and running the code. But we can prevent that. There is an environment variable that we can set. ts-imp diagnose, yeah, diag, and then we set it to error. And then we run here our node command. And if we combine this, then we get to see our stack trace, but then it also crashes the code because the compilation failed. Yeah, ts-imp compile failure, so our code won't get executed, which is very important because if we have errors in there, yeah, we don't want to run in an unknown state. Because if we would run a code that has some issues, then unexpected things could happen and we are not in control. So let's better stop here in control while continuing without control. Okay, let's look at another contestant, which is SWC. And SWC is a TypeScript compatible transpiler. And this is where we should be a bit curious because it says TypeScript compatible. Yeah, compatibility is always something that you have to keep up with. Yeah, let's say TypeScript has new features and you want to be TypeScript compatible. You need to build in these features in here as well, I think. Yeah, and it's implemented in Rust. And the aim is to be order of magnitude faster. So apparently a compiler that you should use, or transpiler, that you should use when you want to have performance and speed. And you can see already how much we need to install. Yeah, it's not just one package, it's 2, 3 packages. Well, it's good that it's modularized. Yeah, so there's a core module and then helpers module. So again, I think there is the problem of compatibility. Yeah, the more you want to be compatible, the more extra packages you need to add in order to fulfill all the feature requirements. And we also see that for some reason it is relying here on ts-node, or ts-node can be configured to use swc. That's also something that I saw here in the GitHub description, that it is a faster ts-node with type check. No, without type check. Oh yeah, okay. So a lot of things come into play. Yeah, we need to install a bunch of packages. It is a faster ts-node, but we've actually had issues with ts-node. So do we want to have faster issues? I don't know. And it comes without type checking, which was actually something that we really liked and wanted to use. Okay, well, for the sake of this video, I will try to make it work here to demonstrate how to use it. There is also here the mentioning of the loader flag and ts-node with ESM flag, or ts-node ESM, or then node with the loader of ts-node ESM. So this all sounds familiar from the beginning of our video. So it looks like we need to configure again ts-node and then tell it to use swc, either through the tsconfig or probably through a flag like swc. Well, let's get into it. All right, I'm back in our project and I installed these 3 dev dependencies. Yeah, let me just show you the install command. So I installed the core, the helpers, and the regenerator runtime. I will now also try to run now ts-node with swc, which is the TypeScript compatible transpiler rewritten in Rust. Yeah, Rust makes everything fast. And they said that I can just use the ts-node command that we previously hard word had, and add the swc flag in here. If I'm doing this, npm start, then a node tells me there's a bad option, swc. So what was the other configuration option? The other configuration option was adding it here in the tsconfig file. So I can have here ts-node section, which, by the way, I don't really like, because I don't like mixing configurations of different tools into one file, because the tsconfig should just be, in my opinion, the configuration file for the TypeScript compiler. Yeah, the plain TypeScript compiler as it is, tsc, coming from the TypeScript dependency. And I don't like to mix in then here configurations of other tools. Yeah, I know that this became also a practice for people in package JSON files, so that people then configure here their jest or other test runners, and I really don't like it. When you have a different tool and it has the opportunity to have its own config file, then please configure it in its own config file. Yeah, that's my personal opinion on that. Okay, enough of the rant. I have here ts-node configured to use swc. Let's run npm start. And yeah, it executes. And is it faster? Well, it feels faster, but let's check. I don't want to believe in feelings. I'm a human. I have feelings as well, but let's let the numbers speak. So if I use the time command here up front, then I will get some performance report, and I have here 0.17 seconds. Yeah, that sounds quite quick. It's all 0.2, 0.18, yeah, all 0 point something. Let's run it again. Yeah, 0.22. Is it getting slower now? No, 0.17. So it's quite quick. Let us remove this here and then run the command again. And 1.98, almost 2 seconds. 1.9, 1.9. So it really takes like a second longer at least, like it's almost at 2 seconds. Yeah. So we have additionally overhead when running it without swc. Here's the website again of ts-imp. Yeah, it said that if you're running tsc no emit upfront to check your types, then you're not gaining much, and that also applies to swc. Yeah, when we have 2 steps in the process, then it will be slow again. ts-imp actually tries to be fast while doing type checks. So here's also like a comparison, not a scientific, but also some measurements from Isaac here. And he said that instead of rewriting things in Rust, yeah, or that meme says so, you can do basic caching and work skipping. That's what also gets this guy here kicked out of the window. Yeah, so instead of rewriting it in Rust, the SWC approach, you should just do smart caching. We tried that with ts-imp, but unfortunately there were then some caching issues that you should be aware of. So still something to see how it performs in the future. Okay, are there any more TypeScript runners? Well, I found tsrun. It's an extremely simple TypeScript runner. Yeah, I say extremely simple because they also say it's extremely simple, but fast. Yeah, you can't probably have all of the things. Let's see how this performs. tsrun and then script ts should be enough. Let's copy that and install it. Back to our code, I will remove the ts node settings to make space for tsrun. I will install npm install development dependency tsrun, and then let's see how it works out here in our project. The start command I will change to tsrun source main ts, and then we'll put it to the test. npm start. Oi, oi, oi. There we have the first issues. Node harmony, no such directory. Okay, let us check our node version, node 22. Let's switch to, let's say 18. NVM use 18. And let's see how it performs here. npm start. Okay, node harmony, no such file or directory. It doesn't run. Let us see. It's probably like node harmony. Probably it has issues with the type system here, like of module, like the ECMAScript module system. Let us go to common.js and try again. Yeah, it doesn't run. Actually, like this harmony flag is a feature flag for older versions of Node.js to enable ECMAScript 6 features, I think, because ECMAScript 6 was also named Harmony, ECMAScript Harmony. There was a code name for it. And the Node team then had this experimental flag that probably got removed along the lines. So let's see what happens. tsrun here will execute from the Node modules and the bin directory the tsrun script. And yeah, here we have the harmony flag, and this one then uses the gbang to execute a node process to then be running that script, and it has the harmony flag. So what happens if we remove that? If we remove that, then we get to see a compile error. This means it got our type check here properly. That's nice. Let us fix it. Then let us run it again. And root is not defined. So now we are running into the next issues. Yeah. So it did type checking. That was cool. tsrun did type checking, but we had to patch that file here, the executable. And now we get into some weird errors with root is not defined. What happens if we use a later node version, let's say 22, and run it? Then, yeah, same issues here. The script is not working. Okay, I will stop at this point. I think tsrun is, yeah, simple, but fast. Yeah, as they said, simple but fast. So they keep their claims. Okay, let us take a few steps back. What have we learned? We have learned that there are quite a few TypeScript runners. There are even like compatible TypeScript implementations in Rust. There are pluggable modules. There are solutions that work with the loader flag, solutions that work with the import flag, solutions that work well with CJS, but not with ESM. All of this is like out there in the world. I will reduce my dev dependencies now to what I think is the best option for now. ts-imp is out because of caching issues. SWC was fast, but doesn't do type checking and needs a lot of modules to be installed and only is compatible, so we don't know how it will look like in the future. So that's also out. Then TS Node is out because it doesn't work well from Node.js 20 and above. You need to configure it with the experimental loader flag, which I didn't like. tsrun, we had to patch here this executable. Let's close it. And then it still wasn't running, but it was fast. So let's also kick that out. And we will end up with tsx for transpilation and then TypeScript for type checking, as Blake already recommended in his supporting thread of TS Node. So please support Blake and TS Node. And for the time being, use the tsc with the no emit flag to do the type checking, and then tsx for doing the transpilation and running. We will also delete here the ts-imp folder. We don't need this cache. And here is a temp from probably the tsrun runner, and we also don't want to have that compiled JavaScript code. Yeah, so let's go back to the bare minimum and see what happens. npm start, and we'll see, yeah, that Benny is being logged to the console, and we have a properly working setup. The only thing that I don't like about the setup is that we actually need two tools to do the job. We need tsc and tsx. And that becomes slow, as we've seen before. So what if we actually change the runtime environment and use Deno? Well, let us have a look. If we execute Deno source main ts, then we'll get to see our console log statement. We have it right there. Yeah, Deno source main ts. And let's use the time. It also seemed to be fast. Well, 0.03. That's even quicker than what we've seen with SWC. And what if we build in an error? Let's say we set the type to number. Then our code still executes. Yeah, we still have the console log statement. But I've heard that Deno has a flag called check. And there we get it. There we have our TypeScript compilation error, and we have the stack trace. We can jump to the file. Cool. So with Deno check source main ts, we have one tool to do type checking, transpilation, execution, and also in a fast way. Amazing. But you need to really know what you're doing here, because we are not on Node.js anymore. Yeah, so we don't need to check the compatibility with Node 18 and 20 because we are on Deno, complete different environment. And there may be issues with Node built-in modules. Yeah, let's say we import something from fs. Yeah, the file system fs from fs. This is how you would do it in Node.js. And just for the sake of this tutorial, I want to see if there is anything in that fs package. Yeah, like the Node built-in modules have functionalities like stats for some file paths. So I want to see if this stat sync method is here. And in traditional Node.js with tsx, tsc, yeah, let me run npm start. We will get to see that this here is actually like a function. So the output says, yeah, it's a function. We hit the function. But can we use that because it's node specific? Yeah, can we use that with Deno? That's a question. Well, let's see. We need to prefix this one with the node prefix. Okay, node fs. So if we want to use a built-in node module, we need to use node prefix. Let's do this. And now let's see what happens with Deno. And we get to see an error that something is not okay here. Like couldn't find a matching package for types node. Maybe I need to install the node typings because, yeah, I'm using node npm install at types node. And then let's see what it will bring to the table. And yeah, we get to see that this is a function. Yeah, so it can use the node package now. And by the way, you can also use the node prefix, and that's a good reason to use the node prefix because it's also allowed in plain Node.js. So if you run an npm start again to run tsx on Node.js, you will get to see that it works. So it works with the Node prefix, the FS module, in Node.js, but it also works like this in Deno. But in Deno, it wouldn't work without the prefix. So that's why it's a good idea to always have the prefix, because it's then also Deno compatible. And let's execute the function with some value. So we give it a pass. We give it a pass to our main file to see what it brings. In traditional Node.js world, we will get then to see the stats of the task of the file, like size and so on. And in Deno, we will then give access to the file system. Yeah, so Deno acts a bit differently here. Yeah, it needs read access, so you need to give it this access. It's a bit more strict, a bit more secure on that level. So this is something that you need to have in mind. Yeah, we are not just swapping out tools here. We are swapping out whole runtime environments that may act then differently depending on your code, on your legacy code. So be really careful when you transport like your Node.js applications to Deno, but at least it's very promising that Deno handles quite a lot of things for us here. So that being said, I think we are on a tipping point. Yeah, the question was like, is this the end of TS Node? And we see that there are a lot of challenges out there. There are a lot of other task runners, even runtime environments, module systems, and we might see a change in the future. Small look into the future of Node.js, because Node.js wants to run JavaScript everywhere, and TypeScript is a superset of JavaScript, but compiles down to JavaScript. And current Node version is 22, yeah, the long-term support version, LTS, but there's also Node.js 23. And if we look into the documentation of Node.js, we'll see that it can also or wants to run TypeScript natively. And since 22.6, there is an experimental feature to support TypeScript syntax. And the support here is a bit tricky, because what it does is it actually removes types from TypeScript, and then it becomes JavaScript more or less. And this will help Node.js to run, TypeScript code. So they just strip the types, take them off the code and then run it. But this comes also with a disadvantage, and that's why they had in version 22.7 to add another feature, the experimental transform types flag, because there are features in TypeScript that are not part of JavaScript and where you can't just strip types. And the limitations are mentioned here in the API docs, because there are limitations like, for example, enums. Yeah, you cannot just strip an enum type because there is no representation for that in JavaScript. So that's why it has to be transformed. Yeah, and this is what the second flag here does. It transforms these enum types into something similar. And there are also features that need to be checked for compatibility. Yeah, for example, decorators. It's coming to JavaScript, but at the moment it's in TypeScript, but not in JavaScript fully yet. So that's why it's also not supported, but soon supported. So there are a lot of compatibility issues. Let's have a quick check how to use it, because then in the future you might be equipped also to run your code just with plain Node, and you don't need then to do some hacks around with TSX and so on. How is this supposed to work with stripping types? Well, we can just then start our TypeScript code by using Node and giving it the feature flag experimental strip types, and then point it to our TypeScript file. It will then do the following. Let's put back some types. Internally, it will strip the type and make a JavaScript more or less. Yeah. So this is what will be done. I will set it to a correct type. Yeah, just to not confuse the compiler here too much, or the Node executable in this case. And then let's see what happens if we run npm start. We'll get to see that our code executes. Yeah, here's the stat information. Here is our console log. And that's quite nice. Be aware that you need a very new Node version. Yeah. So, for example, if we use Node 20, if we use Node 20 and run it, then it doesn't work because there is no experimental script types. If I'm going back to Node 22, then we can run it. Also interesting is now to see what happens with syntax that is not so easy to convert. First of all, let me remove some code here. I want to have some space in here, and I want to now add an enum, for example, enum directions, and I set it to north, east, south, and west. Yeah, now I have my enum. It's not happy because this is how to define an enum. And then when running the script again, we'll see that there's invalid TypeScript syntax that is not supported. Yeah, it's not supported in the strip only mode. So we need to do more than just stripping. We need to also add the experimental transform types flag, this one here. If we then run npm start, we'll have it. Let's see what actually happens if we try then to use our enum. What will come out of that? Directions east. Yeah, I want to see if it is being printed. And yeah, it's 1, and this south will be probably 2. Let's see. Yeah, it's 2. So that's working. That's nice. That's very, very cool. And we also get to see a warning. We have a typeless package JSON, yeah, because we haven't defined a module type here. So it doesn't know like if this is CommonJS or ECMAScript modules. Yeah, I should tell it. And I can tell that to the Node.js executable by putting type to module, and then it should be fine. If I don't do that, I got to see that I can also use new file extensions, yeah, because it says that, yeah, it couldn't detect it and it couldn't be passed as CommonJS, so it's clearly not CommonJS syntax, but there's also no type of module. I could, instead of setting that here in the package JSON, also set it on the file itself by using these new extensions. Yeah, there is now MTS and CTS for CommonJS TypeScript code and module TypeScript code, so ECMAScript modules. If I do it like this and point it then to my MTS file, then it has an error because I also need to fix my code to do the stats here, to run the stats on the MTS file. And this will also then run just fine, and it knows now that it is an ECMAScript module because it has the MTS extension. So we not only have new module systems, we also have new file extensions, new runtimes, new file extensions, yeah, new everything. So there is so much going on. And the last thing for now that is going on that I will show you is that we will get types in JavaScript. Here's the ECMAScript proposal of the Technical Committee 39 for bringing types to the ECMAScript language, and namely JavaScript. So before that proposal, JavaScript couldn't run with types. Yeah, it will create a syntax error if you use a type in JavaScript code. But the idea is that it will run with types and you can execute code that looks this way. And of course, that proposal is still like in the making and is still not something that landed in browsers yet as a full implementation. So give it some time, but be aware that there is community demand for it. Yeah, that's also the repository from that proposal, where there was the finding that static typing is actually something that developers really want. And that's what TypeScript has proven. TypeScript, through its success and wide adoption, has proven that typing makes sense and is something that developers ask for and are happy with. That's why also this proposal here is joined by people from Microsoft. Yeah, so there is also the drive from Microsoft to bring functionality of TypeScript back to the JavaScript language so that JavaScript doesn't need transpilation in order to run with typings. And that's very, very nice, very noble also of Microsoft to have these discoveries and to contribute back to the community, to not have TypeScript like as a competition, yeah, but really as something that evolves over time in the language of all our browsers. Okay, so if you have an idea how to run TypeScript also like smooth on your system with your application, let me know. You've seen a lot of options from me today, and there will be probably big changes coming, and I'm happy to see and excited to see how much easier the workflows will get.